All right, we're on page 2 of the review. I'm going to go ahead and skip number 7. We're going to go to number 8. All right, k of x is equal to x cubed plus 5x squared. We're going to evaluate each function. So find k of negative 8. So from k of x to k of negative 8, x was replaced by negative 8. So in the function, all the x's must be replaced by negative 8, not f. K of negative 8 equals, so all the x's need to be replaced. So something cubed plus 5 times something squared. Now we're going to replace all those x's by our negative 8. All right, k of negative 8 equals negative 8 cubed, which you hopefully don't have on the test, hopefully, because it's kind of a big number. But anyways, negative 8 cubed is negative 512. And then we have plus 5 times whatever negative 8 squared is, which is 64. All right, k of negative 8 is equal to negative 512 plus 320. Which ends up giving us negative 192. So k of negative 8 is equal to negative 192. This interpreted is when I put the number negative 8 into the function k, I get out negative 192. That's what this means. And that's why function notation is so cool, because it tells you a lot of information in very little writing. All right, let's just take a look at absolute value. Even though this seems to be a pretty easy problem, absolute value does tend to scare us sometimes. So we're going to find p of 7, which means that all the a variables will be replaced with 7. Looks like we only have 1, so 2 absolute value 7 minus 3, and then minus 1. So p of 7 is equal to 2 times the absolute value. Now, you cannot distribute into absolute value ever, okay? So make sure you find what the absolute value is before you times by 2. 7 minus 3 is 4, and then minus 1. So p of 7 is 2 times, remember, if it's right next to the absolute value, it does mean it's being multiplied. So I can replace it by 2 times. I can put a dot here instead. And then the absolute value of 4 is just positive 4. So now I'm timesing 2 by positive 4. And that would be 8 minus 1, which is 7. P of 7 is 7. All right, so g minus h of n. This does not mean g minus h and then times everything by n. This is of n, meaning whatever variable you have left will be n. Okay, both of the g is a function of n, h is a function of n, and when you subtract the two, it will be a function of n still. So, g of n minus h of n. That's the same thing as this, same notation. Sorry, a different way of writing it, but using notation as well. So you have g of n is 4n, and then you're subtracting the whole h function. You have to put this in parentheses. Otherwise, you won't distribute the negative, and you'll get a wrong sign. So make sure you put, anytime you're subtracting, you've got to put that second piece in parentheses. So this is actually a negative 1 in front of here. We're going to distribute 4n minus 2n squared plus 4. And then I do like it to be in descending order, so the biggest exponent first. So negative 2n squared plus 4n plus 4. It's not wrong if you don't write it this way, but this is how you should be most familiar with organizing your terms this way. All right, number 11. H times g of n. Okay, so we're going to take this also means h of n times g of n, if that helps to make it any clearer for you. So h of n times g of n. All right, make sure you put it in parentheses because there are two terms in h of n and there are two terms in g of n, and both terms in h need to be times by both terms in h. So it has to be parentheses like this. All right, h is n cubed plus 5 and g is n minus 5. And we're going to FOIL those or use the box method, whatever it is, we are multiplying. So first term times first term is n to the 4th. First outside terms are negative 5 n cubed. Inside terms is positive 5n. And our last term, positive 5 times negative 5, is negative 25. Usually we can add any combined like terms. We don't actually have any like terms for this. So this is our final answer. All right. Now we are subtracting f minus g of 2. Okay. So f minus g, and then we will insert 2 into the function. So this is the same as f of 2 minus g of 2. If that notation makes you feel more comfortable, then that's fine. So f of 2 is actually, let's do it up here, something cubed plus 5 times something squared. And that something is obviously 2. All right, and that is going to give me 8 plus 2 squared is 4 times 5. 2, yeah, let's do 5 times 4. Let's write it out. And then we have 8 plus 20, which is 28. Okay, so f of 2 is 28. Awesome. Minus. Now, I'm going to find g of 2. That's also what I need to do. I kind of ran out of room. So g of 2 is 3 times something plus 5. So our something is our variable, and that variable is being replaced by a 2. So we get, we end up getting 6 plus 5, which is 11. G of 2 is 11. All right, 28 minus 11, 17. So f minus g of 2 is 17. It doesn't need to be written like this, but it just gets us more comfortable with the notation. Okay, h over g of 7. This is the same as h of 7 over g of 7. So let's first find h of 7. 2 times something minus 4. All right. This is 14 minus 4, which is 10. Awesome. So h of 7 is 10. Now let's do g of 7. Negative 2 something squared plus 1, and that something is 7. All right, 7 squared has to happen before you can times by negative 2. So 7 squared is 49, so negative 2 times 49. You can also use the dot if you are more comfortable with that. So plus 1. All right, negative 2 times 49 is negative 98, plus 1, negative 97. And that is g of 7, so negative 97 should go on the bottom. 10 over negative 97, and more appropriate would be to write the negative in front of the fraction. It does not change the meaning. It's just what you're going to see more often, okay? You're not going to see the negative in the top or the bottom. If it's a fraction, they'll generally put it in front of that line.